Hi everyone, my name is Abramov. I work for Facebook. Most of my time at Facebook I spent on code quality testing strategies and things like this. For probably a year and a half I worked on this framework that was open source from Facebook called Jest. So I worked on features like snapshot testing, coverage reporters, assertion library expect, and other stuff. So I really liked Jason's talk before, and there was a slide in the middle that was said something like, make the right way the easy way. So I'm going to talk a little bit about that. So in this talk, I want to talk about how we can apply software development patterns that we use in software development to testing. Because a lot of time when we write regular production code, we use a lot of patterns, architectures, designs, and it's all very structured. But every time we write tests, a lot of times we just write what we think is appropriate in this situation, and it kind of like, a lot of times it's just some random code. So how do we test our apps? So I want to start from this chart. This is kind of like a testing ROI. And on the x-axis, you have effort or time spent writing tests. And then the y-axis, you have code coverage, which doesn't have to be line coverage. It's more like the abstract code quality that you have when you test your application. And what the chart is, and I use this every time I start a new team or a new project. I kind of look at this graph where it shows basically that it's really easy to start writing tests. Every time you create just a single test for your code, you get like 30–40% coverage just right away just because you required file and code one function. But as like you start writing more and more tests, you get less and less and less coverage. And it's really hard to get this last 5 or 10% coverage on your code. And whenever I start a new project, my goal is to find this kind of like a sweet spot. And the sweet spot is a compromise between how much effort I'm willing to put in versus how much I care about quality. And it depends on your application. If you work on some really critical financial application where bugs are really expensive, you probably want to be somewhere on the right side of the graph. If you work on open source libraries, I don't see a reason why you wouldn't test and have 100% coverage because it's like small and pretty important, used by a lot of people. If you work on a regular application, you probably want to be somewhere in the middle. If you work on internal tools or something, you might not want to write tests at all. So how do you approach testing? So every time you start a new application, you join a new project, and you write some code, it's different every time. Every project is different. Whatever worked for you in the previous project that you were on might not necessarily work on the project that you are currently working. So imagine this application structure. So this is some kind of like application that has different modules, that had different types of components. And you joined the team, you wrote your first feature, you created a JavaScript file, and you want to test it. How do you test this module? Usually there's millions of ways that you can approach testing. The easiest way is probably test in isolation. If you created a file, you can just require the file. You call some functions in it. You get some response. You expect that the function returned the value that you thought it would return. You can also test it with kind of like other components and create integration tests where you might not necessarily call your module that you just created. You call other modules that call your module, and you kind of test your code indirectly. You can mock pieces of your application. You can still have integration tests that has some pieces mocked. Or you can test like almost the entire app, but mock something else, maybe like HTTP request or something. So there's so many ways you can test things. And to kind of like know what kind of test you want to create, I want to start from kind of describing what good test is. So in this talk, I want to talk about 3 things. So first, I want to define what the good test is and how to write those. Second, I want to talk a little bit about testing strategies, and I want to have an example that worked for me as a starting testing strategy for JavaScript applications. And then I want to talk about how you can keep those tests clean. Once you found the strategy, how you can enforce it and make sure that you follow the strategy and you make it easy for engineers on your team to write better tests. Okay, so let's start from good tests. What makes a good test? There's multiple things that make tests good. So for me, the most important is probably those. So the test should be fast. When you test, it takes 10 seconds to run. It might not be a problem, but once it gets to like 100 seconds, it may be okay, but once you create hundreds of those tests, you're gonna have a lot of problems with CI pipeline where it's gonna take days to finish your tests. Your engineers on your team are not gonna have instant feedback, so when you change some code and you just wanna ship it, you have to wait for like an hour for tests to run. So if your tests are slow, it's probably gonna be a problem at some point, and it's probably gonna be annoying for your engineers on your team. So tests should not break often. You probably know all those test suites that you change some code or you refactor some code and you think, oh, cool, you load your application, it works in real life, it works in the browser. Then you run your test suite and it's all red because I renamed this function or I changed this API and everything just suddenly broke and you have to go and refactor a lot of tests. So those tests are really annoying, and every time you try to ship something, it becomes kind of like a maintenance problem where you have to spend like 50% of your time on tests, 50% of your time on code. So tests should be easy to read and understand. Sometimes you ship some feature or ship some code, and you run your test suite, and you have a broken test. You open this test, and it's like 1,000 lines of setup logic, some other stuff, and you have to spend like 10, 20 minutes just to understand what the test is doing before you kind of like have idea how to fix it. So the test actually should catch bugs. This is really important because a lot of times we have those test suites that are totally green. You do something, you ship some code, you run your test suite, everything's green, you're like, oh, this is awesome. You open the browser and the application does not even load because some modules were not connected properly. So you don't want tests like this either because they can give you like a false sense of a working code, and you don't want to ship bugs in production. And tests should have good coverage to effort ratio. You don't want to spend 2 hours trying to write a test that tests only one module. Ideally, you want to write a test that is easy to write, easy to maintain, easy to understand, and it actually tests a lot of things together. It gives you a lot of confidence. So again, when you start working on a new project or a new team, what usually happens, you start writing bad tests. And it takes a few iterations to understand whether your test is good or bad, because you can't really tell. You have to write the test, you have to spend some time, see how it performs in master, see how other engineers, whether they have a good time understanding what you're trying to do, whether the test breaks too often or not. And so once kind of like you start writing tests, you try this pattern, it kind of didn't work. You try something else, didn't work, and then you find this good strategy, and you're like, awesome, it doesn't break, it tests a lot of things, easy to read, understand, it's fast, it's great. But interesting thing, so when you have like internal hackathons or quality days, quality weeks, where you put all engineers in one room, and you just say, we're gonna write tests today, what ends up happening if you don't have the good test strategy, you're gonna have a lot of bad tests. Because everyone will start from the same point. Everyone will be like, I'm just gonna write some tests, oh, it didn't work. I'm gonna write something else, oh, it didn't work. And then after a while, every engineer kind of gets to this place where, oh, this test is great. But what you end up with is like hundreds and hundreds of tests that are like either slow, and then your test suite is always red because there's some flaky test or something like this. So what can you do about this? So once you've found this good test, you have to share it with your company or with your team. Once you've found the strategy that works really well, you have to write documentation and kind of like just make people use this strategy, because you've already done the work of like research of how to test your thing, and you have to share it with the team. So now let's talk about test strategies. So I want to take an example project and kind of like take probably the strategies that I go to first when I start working on React applications, and that worked really well. It's not like the only way to test React application, but it's something that I usually start from, and it gives me a really, really good kind of like confidence from the beginning. So let's take the example project. So the project is, it's just a simple counter app. It has a button and it has a counter. Every time you click the button, the counter goes up. So how would this application work? At Facebook, we use Flux. It's the architecture that we built for our front-end application, and it works well with React, the UI framework that we open sourced a few years ago. So for those of you who don't know Flux or are not familiar, I will go a little bit over what it looks like. So the core part of our application is UI. Mostly we use React for this. And UI is kind of like, is this component where you have the visual representation. It doesn't have business logic. It doesn't have any data. It's kind of just like a set of, you can call it templates with some styles, and it's all responsible only for visual representation. So when you want to render your application, you take a data store or something that contains data, and you pass it into the UI component. So the data store, we can simplify it and call it just a simple JavaScript object that has the data about your application. In this example, you have a counter property that has the value of 0. And you render your application this way. So once you start interacting with the application, we have those things called actions. And when we dispatch an action from the UI, for example, when we click a button, we have this event that goes out into the rest of the application. Those events are listened to by mutation modules, or people call it reducers, stores. There's different implementation, but the idea is the same. So when mutation finds this event that is interested in, it goes and mutates the data store and updates some data in this data store. So once data store changed, the UI will listen to events from data store, and it will update and re-render itself. So this is pretty much how UI application works. It's not only React, pretty much a lot of UI application can follow the same pattern. So interesting thing, that mutation layer is usually where the business logic lives, and this is where most of the bugs that I see come from. So it's where you mutate your data improperly, you have some kind of like business logic bug, and all the utilities and other modules and everything else is mostly referenced by mutations. So how would you test this application? So when I start testing any application, I usually put test types into this scale of isolation, from less isolated to more isolated. So on the left side, there's going to be tests with no isolation. They will be tests that render the entire application. They actually go through the DOM nodes and try to find something in there. So for the counter application, you have to render the counter. You have to go and see the HTML tags, find this value, click the button, and use tools like Enzyme or snapshots to kind of like verify that the thing works and this thing works properly. Somewhere in the middle, there can be anything. There can be integration tests of multiple components. It can be UI and the store. It can be mutation and data store. It can be actions with something else. There are a lot of things. And the more isolation is test each piece of functionality separately. So for every module, for every function, you require it. And you call the functions, and you try to see if it returns the value that you expect it to return. So the general principles that I use for describe and test is testing UI is extremely hard. I'm not saying that you should not test the UI. What I'm saying is it's really easy to test plain JavaScript application, because most of that it's usually functions that you call, they do something and they return value. It's kind of simple. Even if your business logic is complicated, most of the time it's pretty straightforward. Once you add the UI layer, there's so much complexity that comes in. There's a kind of like DOM library that you need to use. It's either real browser or JS DOM or something else. All the tests have to be asynchronous probably, because you have to render your application, then wait for everything to be finished, and then you have to navigate through DOM, and there's just so much stuff that you need to do when you test UI. And it's kind of like when you test a plain JavaScript, you spend like an hour in testing your application. When you add UI to this, you probably have to spend 5 hours. So I usually try not to test UI as the first thing. I usually try to test everything else, because that gives me a lot of coverage for business logic, and then get to the UI. So mocking too much reduces test quality. Every time you mock, you kind of diverge from the real world scenario. So if you have the module that works really well in production, once you create a mock, you have the duplication, and you have to maintain this duplication in your test. And a lot of the times you think, oh, my test is green, everything's fine, and then you realize that your mock does not work the same way the real module works, because real module was changed in production, but you forgot to update your mock. And then you your test passes, but the real application doesn't work because the mock is out of sync. And the more isolation you have, the less bugs you catch. And I already talked about it a little bit. So if you test every single module in isolation, you can have really fast, perfectly green test suite. And every time you add new functionality, you think, oh, cool, everything is awesome, tests are green, let's ship the application to production. And you open the browser, and it won't load because two modules are not talking to each other properly. And you definitely want your test to tell you before you ship your application to production that something is not working. You should probably go and fix it. So one of the solutions that worked really well is kind of taking out this UI layer as a first step and putting a test into this. So the test will pretend that it's UI, and the typical test structure would look like you set up the initial state of the application, you dispatch an action, and you expect the data to change. So in real world, it will look something like this. So you would have a test that called increment action. You set up initial state. This is kind of like some utility function that prepares your store for you and gives you as a kind of object, and you store it in the store variable. Then you do a sanity check that the counter is actually 0 and our application is ready to be tested. Then you just dispatch this action, and you expect the store to have a counter that equals to 1 now. And that's pretty much it. So what's good about this test? Failing test is most likely a bug. It's kind of like, it's a really high-level test that it doesn't break for no reason. It will only break if you have a bug in your application, you change the name of your action, or you change your data model, and the counter is not there anymore. And everything else, you can change everything. You can refactor everything behind the action. You can completely change the infrastructure. You can rewrite everything from JavaScript to Reason or something, and it will still work because it tests the action, not the implementation of this action. So the test is very easy to read. It looks a lot like a scenario-based test. So if you go to your coworker and ask them, hey, I have a counter application, how will you test this application? What you're probably going to hear back is, well, you open the application, which means set up initial state. You dispatch an action, or you click a button, which means dispatch an action, and you look for a counter that should go up. And this is exactly what the test looks like. So every time you see the test, it's just straightforward, super easy to read. And those tests can survive major refactoring. Again, if you don't change the action name, and if you don't change your data model, everything else, it doesn't matter. And in fact, a couple of times, we migrated from one infrastructure, from one kind of like Flux implementation to another Flux implementation, and we refactored everything underneath, but the tests were still reusable. And they actually helped us a lot to find bugs during this refactoring. And once we were done, we had exactly the same test. We didn't even change anything. So what's bad about this test? Sometimes the initial setup is pretty hard. It's probably easy for applications like this, but once your application scales a little bit more, it gets pretty hard to understand where all the pieces that you need to just get to the initial state. You cannot really pinpoint a bug. When the test fails, you're probably going to get the message that, well, we expected the counter to be 1, but it was 0. But if you work in small, kind of like incremental changes and you have smaller commit, it's not really that big of a problem, because every time you make a commit and you touch some code, you pretty much know what exactly you broke. And sometimes it's annoying and you cannot really find where the tests for specific files are. So if you wrote a utility function and you put it in some directory and the utility function is used by like 10 actions, it's not really clear where exactly this action should be. But if you have tools like code coverage, that should be pretty easy to understand as well. Okay, so that's kind of the strategy that really worked well and gave us really good coverage just right away, and it's pretty easy to get started with. So once we found this strategy, how do we keep our tests clean? How do we enforce this strategy? And there's a lot of things that you can do about it. For example, you can create shared test utilities. You can generate test templates for your files. You can create lint rules that will enforce that. And you can write a lot of documentation. And I'll go a little bit deeper into each of those. Test utilities. So test utilities are great. So you probably have seen a lot of tests like, I'm going to test my application, and it's probably a simple test that just has one line assertion. But to start the test and initialize the first application step, it's usually pretty hard. And there's always kind of like this application that needs to make a HTTP request to some initial data endpoint. And a lot of times you see tests that have like this huge JSON blob right in the beginning. And you open the test and there's sort of 500 lines of this JSON. And it's really hard to read. And if you have like 15 tests like this that test your initial data and they have the hard-coded fixture, once you change your API endpoint and you change the data format, you have to go and refactor all those tests. Instead, what you can do is you can extract this function and you can put it in something like mock initial data. And you can share it with the team. And you can go to your team and say, hey, if you're planning to test your application, you can just require this module. It has everything that you need. You just call one function, and then you can actually write your test. This is great, because now if you change your application initial data endpoint, all you need to do is just change one module, and it will update all existing tests that use that. So one is probably the best example that I found in open source with test utilities is this library called ESLINT. If you're not familiar with ESLINT, it's a library that analyzes your code and looks for anti-patterns that it helps you kind of like, it highlights them and warns you about them. So for example, so this library works on, it's a modular, and you create different rules for different anti-patterns. So for example, there's the semicolon anti-pattern, and if you have code like this, and you run ESLint on it with this rule, it will complain, hey, you have a missing semicolon. You should correct this. So it's a pretty common practice to write your custom ESLint rules that will search for something specific, and Jason talked a lot about it in the previous talk. So when you create a rule, and every time you want to test your rule, it's kind of like not really straightforward how to test it. The general idea is probably you have ESLint, you have to like set it up correctly, you have to pass your rule, the code with your rule, then you have to have like a code file that you run this ESLint on, and then you kind of expect it to have an error message or not. And if you ask someone to write a test, you're probably going to get like 10 different versions of the same test. But fortunately, ESLint comes with this thing called ESLint Rule Tester. And it's a great utility library that you can use just to write tests for your ESLint rules. So what it looks like, there's kind of like a function that is called Rule Tester, and you pass the name of your rule into this function, and then it takes an object with two properties. So first property is valid code snippets. So it's an array of code snippets that take the code that should not throw any warnings or errors on this, with this rule. And the second property is invalid, which is an array of invalid code snippets and the message that it expects to get. And this rule tester is really, really great, because every time you create a rule, you just don't have to spend time on trying to understand what kind of test, like how do I test it? It already comes with a test utility. You just use that, and it does everything for you. It sets up the ESLint, it passes the right parameters, it passes your rule. And if any of this does not do what it expects it to do, it will give you a test failure, and it's awesome. Generating test templates. So this is my favorite, and it's really great. So if you create a lint rule, we can actually have a lint rule for a lint rule. So when you create a new custom ESLint rule, we can run another rule that will say, hey, you created a file, but there is no test for this file. Do you want us to create a test in this path that will have already the whole boilerplate that you have? It will require the rule tester, it will pass your rule into this, and it will like fill in it will give you like the valid and invalid keys, and all you need to do is just fill in the blanks. And this is kind of like what makes the right way, the easy way, whereas like you don't have to think. You can focus on writing the ESLINT rule code, and testing is just, it's all pre-generated for you. So another thing is we can have lint rules for not good tests that we found. So we can create an actual lint rule for tests that already exist. And when you try to test something in the way that we know does not work properly, because we already tried this, we can create another rule. Like, hey, you're trying to test the module of a type X, but you're not using the test utilities that we have for this module. Here's a link for documentation to read more about this. And this is really great way to serve documentation to people, because every time you join the team, you probably get this link, hey, here's our team wiki. It's like 1,000 pages. Please read it by next week. And you're like, not doing it. But this is really good because it's relevant to what you're doing right now. Because you're probably not going to read all the documentation for the entire company right away. But if you're working on the lint rule and you're creating a test, you get the warning like, hey, this is, we've done this before. This is not going to work. Here's what works. Here's the link for documentation. You just go and read about it. This is really awesome. That what kind of like encourages engineers to learn more. So those are kind of like the practices that we can use to keep tests clean. And so once we found this one strategy, it's not going to be probably the only strategy. We're going to find different strategies for different types of modules. And what kind of like happens after this is that the people that usually kind of categorize tests in these 3 categories. I didn't use pyramid because it's not cool anymore, but it's a square, testing square. So you have end-to-end test, you have integration and unit test. And I don't usually kind of like separate integration and unit test because, I mean, anything can be a unit test, anything can be an integration test. You can have like a function and integration of expressions, right? And you have your application that is a unit of your application suite. But what happens is that those unit and integration tests, they become more like different types of tests. You have UI component tests, data mutation tests, app routing tests, and for each kind of like test, you define what it is, and you're no longer kind of like say, hey, we're gonna go and like spend a week writing unit tests. No, you're gonna say we're gonna go and write component tests, and here's how we write component tests, and this is just kind of like the easy way. And engineers, a lot of people don't write tests, and there was a talk before and probably going to be more talks after. Every time you kind of force someone to write tests, they're like, nah, I don't know how to do it, it's hard to start. But like if you do most of the work for them and let them focus on things they like, it's usually much better. And so this actually happened before. So as an industry, so what I noticed is that 10 years ago probably, if you were interviewed as a software or web developer, every time you get interviewed, you get asked this question about SQL. You kind of want to build websites, but you get asked like, how do you put an index on your database? How do you design your data model? How do you do joins? And a lot of my friends, they were super annoyed because, hey, why am I supposed to worry about this? I just want to build a website. Why do I have to know how to store your data? And then after kind of a while, there's this thing that started happening, especially in big companies. If you work for a big company, you have like this team of 10, 20 engineers, and they have this database service. And they usually provide you 2 API methods, get data and set data. And they like doing this, and they like doing like joins and data indexes and stuff like this. And you don't really have to worry about it, because all you need, you create your application, you have some data, I'm just gonna store it there. And they will figure out how to index properly, how to make it fast and accessible. And what it enabled us as front-end engineers is to focus on things that we like. We wanna make products, we wanna build nice features, and everything about that is taken care of. So the same thing happened with plain JavaScript application. When single-page application became a thing, every single project started from the same thing. What architecture are we going to use? What patterns are we going to use? Is it going to be MVC, MVVM, or things like this? And every time you start the application, there's going to be 10 people that are like, I implemented the model class, and then you end up with like 10 models, 15 controllers patterns, And every time you try to create a new controller, it's like, which one do I choose? This is deprecated, this is a new thing now. And then the JavaScript frameworks kind of started coming out, and there was like Backbone, Knockout.js, Angular, things like this, which is, again, the team of people who tried a lot of things. They tried different patterns, and they found something that works, and they're like, hey, this works. We figured it out. If you just use everything, it's all taken care of. Subclass from this model, and you get everything that is just works just fine. And they kind of like, people who like frameworks, they focus on their framework work, and they just keep extending the patterns and stuff. And if you're a front-end engineer, you can just focus on front-end engineering and not framework or infrastructure. Same thing happened to React. Every time, a couple of years ago, every time we create a React application, the first question is like, are we going to use Babel? Are we going to use Browserify or Webpack? There's so many things. And then they came out with this Create React app, which is kind of like the application that takes all the configuration and pre-configures it for you. And in 2 minutes, you can actually start shipping production code, which is really awesome. And again, it encourages engineers to not like spend 5 days configuring all the things before you can start developing your application, but rather just use something that other people already know how it works, and they know that it works best, and they just kind of start shipping their code. So, and I think testing as an industry is somewhere kind of like close to this, where now we have all those tools that they become available, and that takes this responsibility from people who work on product, and it makes it so much easier to write tests. And the easier it is to write tests, the more tests are going to be written, and the more fun it is to actually work on something that you enjoy working on. Like if you like working on testing infrastructure, this is awesome. There's a lot of work there. If you like working on product, work on product. But it kind of makes you more free, so no one forces you to like write tests if you don't want to. That was actually it. Thank you. And